So yesterday we saw functions. We began with functions and we defined the function, and we defined the function using the def keyword, right? Def keyword. That is what we used. We used the def keyword and then the function name, open parenthesis, and then pass some arguments to it, right? Or we define the arguments and then parameters are passed to it. So that is how we defined the function. So and then we saw how to pass values to a function, right? An input is passed and how we have to kind of process that input within a function. We saw a couple of examples on that. And then we also saw that what are called as default arguments. We saw what is a default argument, and this is primarily an example of it. We define what is called as get power. Get power is a function, and def is the keyword. We passed num, and exponent is equals to 2 is what we defined as the default argument, right? So here, when we did this, we gave num as the input, and exponent is equals to 2 is the value that it takes in a default fashion. So when we are passing or when we are calling it, right, we defined in this fashion, and when we are passing it, get power of 2, 2 is passed in the place of num. And the default value for exponent is taken as 2. That is what we have done here. And then it computes within 2 to the power of 2, and then it returns the output back to the place where it was called from. Similarly, get power of 4, return the 16, and get power of 5, 3. 5 is passed for num, and 3 is passed for exponent. So it takes the value of exponent from 2 to 3 now. It is no longer 2, it is now 3. So 2 is not taken, 3 is instead taken. Whenever we pass something as a value for the default argument, that particular value is considered and not the default value. That is what we have seen. All right. So we have seen what was positional and keyword arguments, right? So in general, if we want to write it, we have seen what was positional and keyword argument. So positional argument is the one for which we are not defining any attribute name or anything which is to be specified as a name. That is what we are not specifying. And here we are passing here the keyword value, right? Keyword and its value. So exponent is equals to 3 is what is being passed. So get power of num is equals to 4, comma exponent is equals to 3 is what is keyword, right? We're explicitly mentioning what is num's value and what is exponent's value here. So it is no longer position based. Now, always the first value that we have is always position based. We cannot have it swapped with something else. It is always position based. So we'll try to understand what it means by taking an example. Let's say we define something like this, print, and I just pass some description as the function name. So print description, and then we pass name, okay? And then I have profession. All right, profession is equals to NA. I give the default value as NA to profession. And then we have area. Let's say area is also passed, and the default value is NA. Okay. Now we write the implementation for this. Let's try to do a very simple thing. And I say name is name, right? And profession is profession. Right, I put that in curly braces, and area is area. Okay, and then I format this. Right, this should make sense to us, right? This is something that we have seen. So I define this function in this fashion. And now for print description, let's say I pass only the name. Let's say we have passed Mayank as the name to it. I use print description. I call this function and pass input variable as Mayank. And then we get something like this. Name is Mayank, profession is NA, and area is NA. That is what we get here, right? Again, we do print description, right? And then I say Suraj. And then I pass the value for profession as, let's say, student. And the value for area, let's say this is Delhi. Okay, that is what I pass the values as. So we have print description, the function, Suraj as the name's value, student as the profession's value, and Delhi as the value for area. And this is basically positional, right? Based on positions, we are passing the values. So when we call this, right, it prints out something like this. The function is taking the input as name, profession as student, area as Delhi. It is no longer considering the NA value, which is the default value. And it prints out name is Suraj, profession is student, and area is Delhi. So it prints this out. So previously, when we didn't pass any values for profession and area, it is still okay because it has default values. And then we pass this and then it takes it. Name can also have some default value. So I'm not considering it right now. But then let's not really worry about it. We'll try to see how this could be done. Right. So then we have Suraj and then I have Satish. Okay. Let's say Satish. And now I say area is equals to Mylapore and profession is sales. Okay. Okay. That is what I pass this value. Now, what has happened is, even though we have changed the order in which the keywords have to be passed, it still considers it, right? Profession is second argument, but we are passing now the parameter as area instead of profession because we are using the keyword, right? We are using the keyword arguments here. Area is equal to Mylapore, profession is equal to sales VP, and then it is being passed here. Okay, so that is what we pass here. And then this is one positional and two keywords. Right, so always position comes first. We always have to consider position and then we can have keywords. That is the order in which we can pass something. What do we mean by position is the first one should always come first. That is what we do. Whenever we want to pass something, positions are always mentioned and then we can change the order by specifying the keyword for it or the name for which the value is specified. That is, or the identifier has to be kept in any order. That is allowed. But if we say I remove this now, then this might not be the correct way of passing it because the second value it expects is provision and then it should be area. So we have to write profession and then this should be area. So, so what I would like you to do as an exercise later is give a value for name as well and then try to change these positions and see what is happening. Okay, try with positional as well as keywords, right? As an exercise, you can try this. Okay, so right now what we have done is we have tried with position and keyword. That is what we have done. We have passed the positional values and also keyword values to it as an input to these arguments, right? That is what we get here. Fine. So we see the preference is always positional and then it comes to the keyword as the preference. Fine. So that is how we will be able to provide default arguments to a function and then use them. Okay, so and then we can write different ways in which we want to use this. If that is available, then it is available. If it is not available, it is not available, right? That is how we can use this particular function for default arguments and keyword arguments. Okay, so that is what we have done. So let's say instead of giving some dummy value like this, we want to pass some list. Okay, let's say we want to pass some list as a default value. So let's try to write some function. Guys, is this clear till here? Any questions on this? Can I move ahead? Okay, so all right. So let's try to write some function like this. Check args, and then I have num as the value. Okay, as the first argument, and the second one is I create something like this. What does this mean is S's value is a list, right? It is an empty list that we are creating. And then I say print the number. Okay, let us print the number and then print. We have S dot append. I use the S and whatever the value is passed. Let's say num is passed, right? S dot append of num. So S is list, an empty list, and we are appending this particular number that is passed to it, right? And then finally, we want to return this. So I return S, right? S is a list that would be returned back. So when we are trying to write this, right, and then we want to call this, right? So I say check args, right? And then I call the function like this, let's say 2, right? And I'm not passing anything to it. So right now, when we are not passing anything to it, this particular value is S and it is an empty list, right? So let's try to run this. And it says return S. Okay. Okay, let's see this. It is giving us a value of 2, right? This is what it gives. So probably I should write this is output, right? Then this would make sense. I would say print output. Okay, so it is printing output, and print of s dot append does not return anything. That is why we see the none statement. This error is because we have a variable that is not defined. That is why it says name error. Name error comes whenever there is a variable that has not been defined, but it is used, right? So now I use output and then I use it here. So so now we get the value as 2, 2, 2, right? That is what we are getting as the value. Because, okay, let me try to rerun this. It looks like this is not the correct way of executing it, right? So now we get the correct output, right? I executed this and then ran it again. Let's say we made some changes to this function. If we do not execute again, it will be the old function. So Python kernel that we are using right now in this notebook, kernel is essentially the instance of this notebook. So it remembers the previous thing. So that is why any changes that we make, we have to re-execute it. And then we can use this function with the new functionality. So that is why I have re-executed this, and then we get the changed output, right? So what I did was remove that print statement and just try to use it, right? That is the change that I have made. So print of num, s dot append of num, and return s, right? This is our function. Now check args of 2. The return value from this function is stored in the variable output. Okay. And then we are printing that output. What is the output? A list. So s is what is being returned, and we have appended 2 to it, and it has printed this value. Now, let's call O1 as the new output, and then I use check args, and then I call 3, right? And then I print O1. What does it print? It prints 2 and 3, right? So list is now being referenced in the memory. The memory or the list that was created is still in the memory, right? So it is no longer empty. 2 was already appended to it. So the same list is being used. It does not use an empty list again. That is what happens, right? So let me try to run this again. So I call this O2, which is output 2, check args, and then I pass 4. Print O2, okay? So now we get the value as 2, 3, 4. So this list that is being used in this function is there in the RAM's memory, right? So previously 2 was appended to it, and then 3 is appended to it. So we have 2, 3, and then we are appending 4. So 2, 3, 4, it is not initializing it always, or the empty list is not being used always. So whenever we use list or these kind of objects, container objects within the function as a default argument, we need to be a little bit careful while using them, right? So this is what happens, and then we get the list as this fashion, right? So if it is being used multiple times, let's say this function is being used multiple times, or it is being called multiple times with this kind of argument, which is an empty list, then we have to be slightly careful and then see how we can use it. So in these two cases above, when we used O1 and O2, it was not empty, and it gave us the list value 2, 3 and 2, 3, 4. That is what was the list value. So how do we make sure that what we are doing is right? A small change we will try to do here is that let me see if we have discussed this. If nothing is returned, we use what is called as none. Okay. So if we had print statement, let's say, I think we'll create a dummy function. Let's say print none or return none. Let me call this function return none. And then I pass num or name. And then I return what is printed in the statement. Okay. I just return the print function, right? Let's see what happens. Okay. That is how I define. So now I say O1 or let's say O3 is equals to R none of some name. Let's say RA. Okay. And O3 is printed. And what is O3? RA is printed because we are printing it here and we are returning whatever is the return value of print. So let's try to see what is happening here. And I try to print O3. O3 has some value that is being returned from the function R none. So it says none, right? Whenever we want to return no value, then we return none, right? That is what we return. None is basically an object. So whenever we try to use print, right? Print statements are used and they return none, right? So that is what happens. So any function like print, or if you want to return something, or if you do not want to return a value, we can return none as well. So this function returns none. It is a valid value. It's just like some value that contains nothing or it is nothing. That is what we could treat that as. That is what is none. It is basically one kind of a value, right? So if we want to check for values, right, which are representing nothing, right, we can use none as a value, right? Or the return type is essentially none. That is what we can see, right? Other way of looking that is, let me write some function that doesn't return anything. Let's say no return. I call this function no return, and then I pass name, and then just print name. Yes, instead of return none, we can write return also, but then yes, that is also something that you can do. But if you do not want to write anything and then also see this, so let's say I want to say S2, right? And then say no return of, let's say, okay, and then print S2. I didn't execute this, so right, it still returns none. So we need not really have a return statement there. It does work when we say return, and rather than writing return none, that is fine. But then let's say we did not write any return statement as well, right? In such a case also, we have this statement, or this functions returns none anyways, right? So it is anyways explicit. So this particular statement, which is not returning anything, which is returning none, is equivalent to what we have written here. Or as our friend suggested, we can have return none or just write return. That is also fine. There are multiple ways of writing the function. If you want to return something explicitly or mention it explicitly, then we can write something like this. But if you do not want to return anything, the last line need not have return statement, or we can just have return, indicating that the function should return its call back to the function. It is the same, because unless and until we have a while loop or something, right, the function will anyways return from the place where it is called. Now, when we write return, it explicitly says that the function has to return now. That is the difference, right? So all of these statements are true as long as we do not have any loops or we do not have any kind of processing logic, and the function anyways return after some time. But if there are functions something like this, and then we expected something to happen, then probably we might have to check what should be done. And then if there is some condition, we write a if condition and an else condition, and then we can have return in that, right? That is something that we can do. That is also fair enough. Fine. So these are multiple ways of getting a none from a function as a return output, right? So these are multiple ways of looking at the function which returns as a none value. Okay. So why is this important is, now the list that we were trying to process, right? It got appended every time it got changed because of a call that was made, right? This is what we had seen. So instead of initializing this empty list, what we can do or modify our function with the way we can write as is check args. We can modify the function in this fashion. So I would say name, and instead of writing the list, I say none. We want for every call of this function that we are making, it should create an empty list. So what we'll do is we'll make a check here. If S is none, right? And then we initialize our list object. Only if S is none, we have to initialize this. And then we can append the values. Now we can come out of this and say S dot append of whatever the value that we have, which is name, and then return S. So every time we call this function, S will be none. It is not referencing to the list object that we have, because while the function is called, the list is also being created in the memory, and then we will be appending to the same list object. But this, now we make an explicit check where the list is empty or S is empty, only then S should be initialized as a list, right? That is what we are trying to make a check here, and then we can call this. So let's try to do the same check that we had done earlier. So I'll call check args of 1 first, right? I think the variable is the same. Let me call this S1, S1, S1. It is referring to the same object because what has happened?
So that is check args1, sir.
Oh, check args1. Yeah, I'm sorry. Right. So I thought it was the variable. Let me try to do this. Okay. So, and then we return as. This should be name. Okay, this should be num. We are using nums, right? So let us make this num only. Previously, we had used name in our previous functions. So let me try to do this. All right. So now we get 1 as the list, and then let me try to run again with the value 2. Now we get 2 as the list, and then let me try to run this again with 3 as the value. Right. So this is how we'll be able to make a subtle change with respect to how we are providing the default arguments, right? So this is the change that we might have to do in our code, and then also check this condition and only then initialize it to an empty list. Fine. Does this make sense, guys? How the previous function was different from what we are doing right now? Any questions on this?
So like for every collection, so we can use none, right?
Every collection that we have, it can be used as none. Absolutely.
Okay.
In fact, any object that you have in Python can be used with none. A string can be checked for an empty string value or a none object. Or as we use classes or anything else, if you're doing even object-oriented programming, this can also be used the same way. Okay, so that is what it is, and then we'll move on to next usage, which is essentially star args and double star KW args. This is essentially unpacking of values. So how do we kind of use this, right? Let's try to understand this based on a simple example, and then we'll try to see what is happening, right? So let me define one function first, right? We'll use the same thing. I call this print description. Okay, and then we'll use the same thing, name, and then I'll use profession as well. Profession is equals to NA, and then I'll use args, star args, and then we'll use KW args. So this particular example that we'll try to use is essentially, we'll try to understand it from an example point of view rather than trying to first define it and then see what is happening. We'll do it the other way around. We'll first run an example and see what essentially this star args mean and this double star keyword args means. So, and then we'll see how unpacking is done within the function, right? So to give a brief thing here, args is referring to arguments. That is what we'll try to see here. And then kw args means keyword arguments. Okay, that is what this means, first thing. And should we name always this as args? Then not needed. This could be any name. Args is just a argument name or an argument variable, whatever we would like to call it. It is just an argument variable. Okay. And what does the star indicate? We'll try to see how it unpacks values, and what does the double star means with respect to a dictionary. We'll try to understand that. Okay. Not needed. It's just a argument variable name, right? That is what I wanted to tell here. This is a argument variable name. And similarly, kw args is just a argument variable name. It need not be kw args. But then while we use it, while we define this multiple times, the standard way of utilizing this has been args and kw args, just like the way we start with a variable name as x or name or num. That is how this has been put it that way, args and kw args, right? These are just variable names. All right. So now we have this print description. The next thing that I'll try to do is I'll say print name. Fine. And then, all right. Otherwise, I'll print everything. Okay. Let me try to print everything. Name is name. Then profession is profession. Right. And then for now, we'll call this as args value is. Okay. And then we'll have args, and then we'll call this as kw args value is. Kw args. Okay, this is what we have. And I think I have to make one change. Let me come to the front of this statement and then do this. All right. Is there anything else? Right, that's it. And that is what we'll try to do now. We'll see what it means, and then we'll use it. Okay. So now how do I call this, right? So I call this in this fashion, print description. And name will pass Mayank. And then profession, because we'll use positional. So I'll try to use this in this fashion, right? Positional for profession is, or let's do this. Profession is equals to, it becomes keyword. So profession is equals to lecturer, and then we have args, right? And there is a star. So now I want to add some statements here. Let's say we want to add teaches physics at college, right? And specializes in nuclear energy. Okay. Okay, that is what I pass. And then it is not ended. We have kw args, right? So what I'll pass here is key value pairs, right? So let's say I pass institute name is equals to bark, okay? And then I want to pass one more thing. Let's say location. Location is Western Mumbai. That is what I pass this value as. Okay, that is what I pass. So we have here the name's value that is being passed, which is a parameter. Profession is lecturer, teaches physics at colleges, specializes in nuclear energy, institute name Bark, location is Western Mumbai. Right, so I've passed two values here and two keyword values, right? Which is the identifier institute name and its value is Bark. Again, an identifier location and its value as Western Mumbai. That is what I passed, right? Let's try to execute this. I've already executed the previous cell. So the function is already defined as print description. I'm just overwriting the previous print description. So I think this should work. So let me try to run this. So something went wrong. All right. So is because of this enter or oh, I think I have to remove this. So let me try to remove this. This will is causing the problem. So let me come to this again for now. Let me try to remove this for now. Oops, profession is okay. Yeah. Right. So what has happened here is we passed the name here, which is Mayank. And then we have star args, and then we have double star KW args, right? So what has happened? So first we have the positional arguments value as Mayank, and then we have for star args, we are passing two values, correct? This is what we are passing. Okay. Teaches physics at colleges and then specializes in nuclear energy. And then we have institute name as BARC and location as Western Mumbai. So let's try to see what exactly is happening. So it says args value is teaches physics at colleges and specializes in nuclear energy. This is what is coming for args, right? These two values are being passed for args. Okay. And then for KW args, right, we have institute is equals to BARC and location is equals to Western Mumbai. So for KW args, right, we are getting this particular value and then I can pass profession here and then I'll add this profession here. Okay, let me try to add profession is equals to lecture. Okay. Right now we get the value as profession, right? So what essentially this args and KW args are doing is that they are trying to take as many values after this positional argument. So let's say we had only one instead of these two. Let's say I had only this particular, let me comment this out and then show you what we'll pass to it. So let me do this and then remove this particular second value that we have. He teaches at specializes in nuclear energy. Let's try to hide that value for now. Right. And then what we get is args value is teaches physics at colleges, right? That is the only value it kinds of gets it. So as many values that we want to add, we can add here, right? And then we say specializes in atom at nucleus level. Okay, that is what I'm trying to add again. So now we get all those three values, right? So we get teaches physics at colleges, specializes in nuclear energy, specialized in atom at nucleus level. And then KW args is institute name BARC, location Western Mumbai, profession is lecturer. So we are adding more values, it kinds of unpacks them, right? Args unpacks them and KW args also unpacks them. But how do we use them, right? So args is essentially taking the values that are separated by commas that we have given here. And KW args is taking those values that are keyword in nature, right? All those that are there in keywords, it tries to take those values and present them as a dictionary. Other thing that it presents is KW args or keyword args presents these values within the function as a dictionary, and args present these values as a tuple, right? So we have to unpack them. So how do we unpack them? Is like, let's say we have a comma b comma c is equals to args, right? And then when we run them, and then I also print a comma b comma c, right? We get the values, right? We get teaching physics in nuclear energy, or if you have to, make this look better, I just add spaces in between them. And execute it, right? So now we get these values. Teaches physics at colleges, specializes in nuclear energy, specializes in atom and nucleus level. So this is what it does. So args kind of takes those values whenever we are not sure of how many we want to pass, right? Let's say we want to pass one or more than one. Even if we do not pass, it is still fine, right? If we want to pass arguments and then unpack them as the values they are, then we can pass them as args separated by commas like this. This can even be a integer. Let's say I pass this as 10 now, right? You see this 10 here, it gets printed out, right? So we can pass this as an integer also. So whenever we are not sure of how many parameters we want to pass to the function or how many arguments the function can accept, right? In such cases, we can use args or kwargs. Kwargs is essentially for identifying the key and the value, right? So how do we identify this? Let's say we have institute name, location, and profession, right? In one function call, we pass profession, right? And in another function call, we do not pass profession. I am doing this and closing this here, right? I do not pass profession in this case. I pass profession in the one function call and I do not pass here. So here, what I'll do is if length of kwargs is greater than 2, only then print this particular statement. Okay? That is what I have done here. Only if it is greater than 2. So for the first function call that we have written, print description, the name, then the values that we want to pass, and also the keyword arguments, institute name, location, and profession, right? This is the case where we have keyword arguments more than 2. We have institute name, location, and profession. It is in fact 3. For the second case, it is only institute name and location. There is no profession to it. So it is not getting executed, and we see only this getting unpacked. The tuple values are getting unpacked. So args gets the value as tuples, and that is what we are assigning to variables here. And similarly for kwargs, we are trying to get the values as dictionary. And if we know this, let's say I want to print the profession only when it is greater than 2, then I would say something like this: profession is, in this particular thing, kwargs of, the key is profession that we are passing, right? That is what we are passing as the key. This is our key that we are passing, profession. So I use this key to get the value, right? kwargs is just a dictionary name. That is what is being considered within the function. What happened? Oh, is not defined. We passed it, right? Oh, I see. I get it. Here, the variable is not there. It expects a variable and it is not there, right? So we will try to do this something like this. Still says name error. It is greater than 2, it should be available, right? Or let me check this. Just give me a second. Question in. Oh, okay, I got it. I think we have to just enclose that in a single quote. The reason is that is how the dictionary is presented. So let me try to add this here. Just give a minute. All right. So, right. So that is how we get it. I think I just have to rename this and then, okay, we can do that in the print statement, but this is how we get the value for the profession. So KW args of profession, right? This is what we get as the value as lecturer. So it is extracting that. So KW args is basically a dictionary within that function, right? So that is what we try to do here. So for KW args, it is unpacking it as a dictionary, and args, it is unpacking as a tuple. And this is how we can use args and KW args. And when do we use this? When we are unsure of how many keywords are to be passed or how many, comma separated values have to be passed with respect to positional arguments. In such cases, we will use star args or double star KW args. Right? Is this clear, guys? Any questions on this? All right. So if there are no questions, then what we'll do now is we'll try to take a look at how do we define functions in an IDE. I hope this is clear, right? Any questions here, folks? If something is not clear with respect to star args or double star KW args, we may review it again. Any questions on this? All right, if there are no questions, then what we'll do now is we'll move on to a function. How do we define it in a IDE? So let me try to take an IDE like Visual Studio Code. Okay, I take this Visual Studio Code, and once you open the Visual Studio Code, you say new project, or you could specify any project, and then you can open a workspace or you create a workspace and then start working upon it. Okay. So I'll say here as new text file. And before you start using this, I would request you to install the Python extension. Okay. If you install the Python extension, you will be able to run Visual Studio Code. So where is the Python extension? You will have something like extensions here, and then you can type Python. Okay, and internet should be connected in order to use the extension. And then you will have the Python extension for the first place here. Just see this, it is available here. And then you see a button like this, which is blue color in nature, which is essentially telling us to install. Click on install and it will install the extension. Fine. So this is the icon for extension, and we can search the files, and there are other aspects also. If you want to run, there is an option here. You can run and debug using this option. And if you want to connect to any version control repository, we'll be able to use it. Or if you want to run it from a file, we can do it in this fashion. Okay. So I have the workspace ready. That is what I have done here. And now I'll try to create a file. Okay. I'll call this as new file. Okay. And this shows up like this. And I'll call this file name as let me call this as iterative. Let me call this, what are we doing? We're doing functions, right? So I'll call this as functions 01.py. Okay, I'll call this as functions 01.py. And this opens up a file, an empty file here. And once you install that Python extensions, then it will automatically search for how this is being done. And at the bottom of the screen, you see here, right? This shows the interpreter or the language that we want to use. And if you type in Python here, right, you will see Python here, and then click on it. It will be selected and we can start running this in Python. right? So that is how we'll be able to see do it. So you can select the interpreter from here. Right now it is showing as 3.9.13 64-bit interpreter, right? At this space, lower bottom, right? To the right side, right? Just above the Windows tray that we have, you see this and you can check select the Windows interpreter at this point, right? Right. And then for this, what I'll do is I'll try to create a function, and we have seen how to call a function. So I'll create the main block. So I'll use if underscore underscore name underscore underscore is equals to, then in single quotes, I use underscore underscore main underscore underscore, and then colon, I hit enter, and then just write pass. Okay, we are not using this for anything. And to specify what this file is, I'll use triple quotes. Okay, this is an example. So to comment out on, to comment and then also specify what is being used in this file, I use this triple comments or triple quotes comments. This is an example on functions, right? Can be used to call it. Okay, a function can be used to call it. Okay, so but then it is not complete, so let's complete it later. But right now what I'll try to do is I'll try to write a function called as so only the Python extension for this class. So you would need just the Python extension right now. That would be sufficient. Now if Visual Studio Code is not working for some reason, right, go to this ID, which is spider ID. You see this spider ID, right? You can also use this. This is already there with Anaconda. If you have installed Anaconda and not installed Visual Studio Code, you can still use this particular IDE, spider IDE. For this, we don't have to install any kind of external extensions. By default, this is inbuilt. We do not have to externally install anything. So from the Windows prompt, you can type in spider, SPYDER, and then click here and then say new file, and it creates a new file. And if you want to save it, just do a save as, right? And then we can save this file as function01.py. Okay, so both of them are good. If you are not able to install the extension, you can use the spider ID as well. Fine. I'm just trying to show you Visual Studio Code because the other day we could not spawn it, and some people were using Visual Studio Code that day. So I wanted to show this. So this is how we can use Visual Studio Code, but the same thing can be done in Spider IDE as well. This is the Spider IDE that comes packaged with Anaconda, right? The same thing we can write here. So I'll move the code here. Once I write it in Visual Studio Code, I'll move the code to Spider IDE, and you'll see there is not much of a difference between the usage. So I write this function as iterative factorial. Okay, I write this as iterative factorial, and then pass input as n. Fine. And then I'll initialize a variable which is called as result is equals to 1. And we want to find the factorial of a number. So I say factorial for I in range of 1 to n, or it could be either then we did not have to do n or n plus 1 till n I want to compute, right? This is what I do. And then I want to do something like this. Results is equals to I into result. What does this mean is we want to compute the product of what is I. It begins with 2. So 2 into 1. And we know factorial, right? Factorial is essentially this. Factorial for a number n. Let's say we want to compute 10 factorial, right? 10 factorial. So this would be 10 times, 9 times, 8 times, 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1. this is what is 10 factorial. That is something that we know. So for n factorial, it will be n into n minus 1 until 1. That is n factorial. So, but then we will write this in this fashion because we are starting from 1. I'll say 1 into 2 into 3 into 4 into 5 into. So we are coming it from the reverse order, and this goes on until the value n, right? This is what we are trying to do here. So for I in range of 2 to n plus 1, result is equals to I into result, right? That is what we have, I into result. And what is I? I starts from 2 and it goes on until n plus 1. N plus 1 is exclusive. It is not inclusive, right? This is something that we have seen in range. So we are computing it correctly. So we get the value for n factorial and return result. So every time we are multiplying I with the result, initially it was 1. So now it is 2. So it will be 2 times 1. Next time it is 2, it will become 2 times 3, right? So on and so forth. Next time it is 4 into 6, right? Or 4 into 3 into 2, right? This is how it keeps on computing the value, right? Or 3 into 2 into etc. Whatever the value is, right? So it keeps on computing that particular product. So now we are having this result, which is nothing but the factorial of the number. And then we call this particular number, we call this particular function from this place, right? So instead of pass, I remove this. Now we have an implementation. So I say print of iterative function of 5. And 5 factorial, we know it is 5 times 4 times 3 times 2 times 1, which is nothing but 120, right? So how do we run this program? You have this run symbol here, right? Run code, that is what you see here. You can just say run code or run Python file, or just click this right triangle symbol that you see on the top side. Just click this and it runs the program. And right now, what has happened? Did I save this? I have to save this. Okay, let me save this. Right, it prints 120. So previously I didn't save it, so it didn't print out anything. Now I've saved this. So I did a Control S, or you can do it from file and then save it. So both are the same, and then you can run this program, right? And as you see in the console output below, this is the output window that you see here, right? So we see 120 as the output, right? So that is how we'll be able to call this function within a file. We define the function and then call it from if underscore underscore name equals to, and then main function is put in single quotes underscore underscore main. There are 2 underscores and then 2 underscore and then single quote colon print of this particular value. So what I'll do is I'll put this in our ID, which is the spider ID. Hope everybody is able to see the spider ID, right? This is also shared. Can you see it, guys? Just give me a thumbs up if it is available. Right, so you are able to see the spider ID, right? So now I have written the same function here, and all that we have to do is just let me try to zoom in more. Or probably this is not zoomed in properly. Yeah, now it is better. And then in order to run this, you see this green button here on the top, just below the file menu. There is a next bar to it where you have file folder and then the green symbol. This is run file, or if you want to use the shortcut, it is F5. And the output will be there in the right side. You see this console here, the output will be printed here. So let us run this once. And this also runs it in the same way. It says it uses some function called as run file. Whenever we want to run files using system calls, we use this run file. And it runs this file. And then 120 is printed. Right? So that is what is printed out here. We get 120 as the value when we run this. So it's the same thing. If you want to run it using Jupyter, this is Spider IDE, you can use this. This is packaged with Anaconda. But if you want to use other IDE, the more famous ones these days is Visual Studio Code. This can be used for any programming language. But Spider IDE is essentially used only for Anaconda, and that is for Python, right? That is what it is packaged with. Exclusively only for Python. That is what we use Spider IDE. But if you want to use other programming language, if you want to use Python, Java, C++, any other programming language, and you also want to have this integration with GitHub or any other version control system, then Visual Studio Code is a lot better than compared to Spider. for development purposes and just for to practice, Spider is more than enough. But if you want to do a collaboration and then start working and use some servers, or if you want to use other programming language, everything in one, then Visual Studio Code will be a preferred choice, right? We can also use JavaScript in Visual Studio Code. That would be how extensive it is. It provides a lot of extensions. Fine. So that is the difference between Visual Studio Code and Spider IDE. Both of them can be used for Python. So any one of them is fine for our exercises. All right. So next one, hope this iterative factorial is clear. Now the same thing, we can do this using what is called as recursion, right? We have used this iteratively by using a for loop, right? This is essentially a for loop, and then we have iterated over, and then we have called this function multiple times, and then it is running. So if you want to kind of use this, right? Let's say I want to write this, but then, okay, let me try to say new file. Then I call this function 02.py. Okay. And then I want to run this program in a different way, but let us try to run a simple recursive function and then write it for factorial. Right. And what is a recursive function? Recursive function is something that it calls itself multiple times, right? That is what is a recursive function. So I call this as a recursive exercise or recursive example. Sum of numbers. How many numbers? We'll pass n. Okay, that is what we'll pass to this particular example. And then I use the same thing, if underscore underscore name underscore underscore equals to in single quotes underscore underscore main. And then I write like this. So whenever we want to start a program in Python, right, it is better to use this main function. This would become the starting point, right? Rather than just having lines of code, we can have this particular main function, and whatever we want to print or whatever we want to do, we can start it from here. This would become the starting point. So let me define the function. I call this def and then sum of n. Okay, I call this sum of n and I pass an input n. Okay, and I define this function in this fashion, colon, and then again the same logic we'll use. If n equals to 1, right, we'll do something, we'll return 1. Okay, we want to return 1 if n is 1. So for a recursive function, right, it kinds of takes some recursive, it kind of executes it recursively. We need something called as a base condition, and our base condition is that if it comes to 1, what should happen? It should return 1 value. And why do we want to do this 1 value is because of our logic that we are going to write so that our base condition is met. And what is the logic? Logic is this, is something like we write it in else. If n is not 1, what should happen is we want to return the sum of values. How do we return the sum of values? Is by calling sum again, and I decrement sum and then call this as 1. Okay. So what is happening here is, let me try to explain this. So whenever we are calling this 5, let's say we are passing 5 to it. So it comes within this loop. N is not 5, so it goes to L. It goes to else block. Let's say first value is 5, right? 5 is there, and it goes to the else, and then sum of 4 is called, right? And then we have 1. So for the first call, we have 5 plus 1, right? And then we go back. Sorry, this is 4, right? For 5, it is 4, right? For 4, what happens is, or it is sum of 4. I would not say 4, it is sum of 4. Sum of 4 plus 1, but sum of 4 is called again. It goes, sorry, this should be sum of n. I'm sorry, guys. This should be sum of n. This should not be sum. This would not be executed properly. So we call sum of n minus 1. So sum of n of 4 will be called, and it goes here again. And it comes here, n is not 1 because this condition is for n equals to 1. So it comes to else. Sum of n of 4 minus 1 is n minus 3. So this would call again sum of 3, right? And sum of 3 again goes inside, right? And then it sees what is the value, right? 3 equals to 1, this does not meet, it comes to else block. So again, it calls sum of 2, right? And then it calls sum of 1, right? For sum of 1, what happens is 1 is returned, right? So 1 plus 1 or sum of 2, n is equals to 1, return 1, we get 1 plus 1. And then for sum of 2, we already have the return value from 1 plus 1, 2. So we'll try to add for sum of 2 and we'll get the value for it. And then we'll have the value for sum of 3 and finally the value for sum of 4, right? These values will keep coming in this fashion. And then the sum is obtained, right? So let us try to run this once. Let's say I do a sum of 5. And let me try to run this. Oh, sum of n. I'm just calling this in this fashion. So try to run this. We are not printing it. So let me also print this now. Well, looks like this is returning 5. Just give me a minute. Sum of n minus 1 plus 1, or this is, check the logic again. Just give me a minute, guys. Oh, sorry, this should be n, right? Because 5 plus 4 plus, okay, this should be n. Now it is correct, right? So this should be n. So we'll have 5. Then it will go for sum of 4. We'll have sum of 4 plus 5. And then finally it will come to 1, right? Then this should be fine. So 5 plus 4 plus 3 plus 2 plus 1, right? So this is how it should be. Right now it is coming correctly. So it is 15. So for the first case, we have sum of 4 plus 5. So sum of 4 plus 5. Let me try to write this again. It will be sum n of 4 plus 5, right? And then for sum of 4, it will go inside, right? It will come in. If n is equals to 1, it will return 1, but the condition is false. It will come to else. So sum of 3 plus 4, right? It will do sum of 3 plus 4. So sum of n of 4 will be sum of 3 plus 4. And previously, it is 5. So sum of 4 is sum of 3 plus 4 plus 5. And then we have sum of 3. Sum of 3 will be computed as sum. This is not sum n of 3, sum n of 2. And then there will be 3 plus 4 plus 5. And for sum n of 2, it will be sum n of 1 plus 2 plus 3 plus 4 plus 5. And finally, now we have 1. So 1 will be returned, right? So we'll have 1 plus 2 plus 3 plus 4 plus 5, right? So this is how it will be computed. Sum of 4 is not yet completed. So it will call again. It will evaluate of sum of 3 plus 4. Again, it will call sum of 2. Sum of 2 plus 3 is there. Again, we have 4 plus 5. Sum of 1 is there. Sum of 1 is not evaluated. So it will come here. So it will come to the if block. Its value is 1. 1 will be returned. And then we get 1 plus 2 plus 3 plus 4 plus 5. So whenever we want to compute recursively, right? It tries to, we call the recursive function again within the code block. And we have our condition here, which is basically the base logic. And our base condition is this, which is essentially saying that whenever the value that has to be returned has to be checked for, and the last value is 1, and beyond that, we do not want to check it. So if n is 1, it should return the value of 1. We are subtracting, so it goes on till 1. So what is happening here? For the first case, sum of 4 plus 5, sum of 4 is not computed, so it goes in. Sum of 3 plus 4 plus 5, sum of 3 is not computed. It again calls this. Sum of 2 plus 3 plus 4 plus 5. So we have this value. So this values is maintained. It is not computed immediately. 5 or 4 plus 5 is not computed immediately. 3 plus 4 plus 5 is not computed immediately, because this function call is still happening. Once it returns 1, and then it starts computing the summation 1 plus 2 plus 3 plus 4 plus 5, which is essentially 15. Right? So this is how it starts iterating and then starts computing the value. Okay. So we kind of write this recursive function in this fashion, where recursively we are trying to call the function again and again. Right? So this is an example of sum of n numbers, and n could be anything. Let's say we want to calculate it for 10. So for 10, it should give us 55. Let's check that. So it is giving us 55. If it was 15, it should give us 120. Let's check that, right? It is giving us 120. Fine. So sum of n numbers is computed recursively in this fashion, right? Now let's do the same thing for factorial, right? We have done this for summation. Let's try to do this for factorial. Let me try to create a new file, and I call this function 3. Okay, and let me comment this as factorial computation. Fine. And then I define a function called as factorial. And we pass this as n again. Again, what is our base condition? In this case for factorial, if it hits 0, right? If it is 0, then it should return 1, right? It keeps on subtracting. For some, we subtracted it, right? So it was only till 1. For 0, there is nothing. So we do not want to do it. So it should return, when n is 1, it should return 1. But in this case, when n is 0 for factorial, it should return 1. That is our base condition. And then I write the else block. If n is not 0, what should happen? We will compute the result, right? And result is computed in this fashion: n times factorial of n, right? And we want to return the result. Okay, result is equals to n times factorial of n, and then we want to return the result. So in this case, again, I try to write the main function if underscore underscore name equals underscore underscore main, and then I call this function print factorial of 5. Right? Again, the same thing. First case, we get factorial of 5. First time factorial of 5 is called. So it comes inside this function. Factorial of 5 is, it is inside this function, factorial of 5. And n is 5. So it will not come here. It will go to the else block. In the else block, we have 5 times factorial of 4, right? So it comes to else and it evaluates as 5 times factorial of 4. Okay, this is what it evaluates. Now, for factorial of 4, it is still not computed, so it does not return anything. Okay, it does not return anything. Result should be under else. It should not be under the if, right? It should be within else. So I have just made this indentation properly. That is what I have done here. And then for factorial of 4, it will be, again, n is 0, so it will not go here. It will come to else. So it will come to the else block. Result is equals to n times. So it will compute n into factorial of 4. Right? So now it is not computing this factorial of 4 because it stores the result, right? It has to return the result, right? It has to return the result. So it does not compute and it is waiting here. So it is not returning anything from here. So factorial of 4 is still here. So let me try to draw this and show you again. Let me go to this particular place. So let's say we have, first thing is factorial of 5. Right? Factorial of 5 is essentially 5 times factorial of 4, right? But factorial of 4 is again going to the function. So it comes here. So now we'll have factorial of 4. Right? In factorial of 4, we have 4 times, because factorial of, we are not returning anything because factorial of 4 is not computed. It goes here. 4 into factorial of 3. Right? So this is not computed. So it again goes to the function. It comes here. These are all defs that we have. Def of factorial, def of factorial, and def of factorial. Each time this is happening. And now at this place, this is factorial of 3. So it will be 3 times factorial of 2. It is still not returning. So we have factorial of 2. It goes here. This is again def of factorial of 2. So it comes here. So here it is 2 times factorial of 1. It is still not returning. It computes factorial of 1. So we'll have factorial of 1 here. Right? So this value goes here. Again, this is def of factorial. This is factorial of 1. Right? So this is 1 into factorial of 0. Right? It goes again. There should be another function call here. So it again goes to def of factorial of 0. And we see factorial of 0 is 1. So it returns this value to here. So now we have this as 1 into 1 is computed. 1 into 1 is 1. It returns this value to factorial of 1. So we get, right, this is all factorial of 1. This is factorial of 2, right? So now here we have factorial of 1's value. So this is again 1. We have 2 into factorial of 1. So it returns to the place where it was called from. So this is 2, right? And we have 3 into factorial of 2. So this becomes 6, right? Factorial of 2 is 2. So this becomes 6. So this is returned to factorial of 3. 6 is returned to the factorial of 3. And we have 4 into 3. 4 into 3 is 4 into 6 is, right, this should be 4 into 6. This will be 24. So now we have 24. 24 is returned to factorial of 4 here. And still it is 5 into 4. 5 into factorial of 4 is 24. So this value will be 120. Right? This is what we have as the return statement. We have the return statement for 120. So this is returned. So we'll have function calls and finally the return types for each of those functional calls. It starts from factorial of 0. Right at this place. Factorial of 0 is 1. So that is where it gets returned. Factorial of 1 is 1. Again, it multiplied with 1. So factorial of 0 is 1 multiplied by 1. 1 is returned to the place where factorial of 2 is there. Factorial of 1 is 1. 1 times 2, which is 2, that is returned. You have factorial of value 2 computed now. 2 is multiplied with 3. The output is 6. It is returned to factorial of 3's place. 4 into 6 is 24. 24 is again returned to factorial of 5. 5 times 24 is 120. So we get this output of 120. Now this is being returned. So this is how a recursive evaluation call happens. And this is basically called as the method area or the stack frame. So this is called as the method area. This is how it gets constructed within the RAM for a programming language, right? This is a method area. That is where this recursive calls are being happening. And until and unless the base condition is reached, till that point, this happens. So, right, this is our base condition, which is 0. Let's go back to our program, and this is what is happening. So 5 times 4 into factorial of 4.
Sir,
Yeah.
I think it is result is equal to n into factorial of n minus 1.
Result is equals to n into, yeah, you're right. I wrote it as n, right? It is factorial of n minus 1. You're absolutely right. So you're right. So whatever we discussed is for n minus 1, but however the program was for n, so we have changed it to n minus 1. This is n into factorial of n minus 1. Every time we do this, so this is n minus 1, right? Every time we are doing is that, but in the program it was not written. Right? This is what we are trying to do it. And it kind of evaluates this, and 5 times factorial of 4 is 5 times 4 into factorial 3, and this becomes 5 times 4 into 3 into factorial of 2. These computations are not evaluated, and then it comes back here, right? This is what we are trying to do here. And let's try to run this. Factorial of 5 should give us 120. Right? It gives us the same thing we can check within the Spider ID as well. Let me try to create a new file quickly, and then we'll try to do this. I name this as function 2. And let me zoom in a bit, then save it and then run it. Right, we get 120 here as well, right? So this is how we write a recursive function in Python. Guys, any questions on this? What is happening with respect to the recursive function and what is happening and what is being returned each time? Any questions? All right, if there are no questions, then we'll stop it for today. And then tomorrow we'll see other topics that are pending. All right, till then, good night and goodbye.